This week we're going to talk about hearing. First week we talked about basically the understanding of the recording industry and its development. Then we talked about the characteristics of sound, frequency, wavelength, those basic concepts of how a sound wave is generated. Last week we got more into detail about the behavior of sound. This week let's talk about how we hear sound, and then we've got both avenues covered and we'll start into the recording part of it. This is actually a really interesting week for me because I always find it fascinating to understand how we hear. As everybody, we all have ears and we all hear, but I didn't understand until I really researched this and learned about it, actually how complex your hearing is and how tremendous a sense that human hearing is. So let's start talking about it a little bit, and you can sort of get the sense of how your hearing works. So the first thing we need to do is talk about physiologically how your hearing works, just the mechanics of how your ear works, right? Which is what people studied to learn about how sound could be recorded. They studied the human ear. And then psychoacoustics and our perception of sound. Psychoacoustics is how your brain perceives sound. So not just the mechanics physiologically as to how your ear works, but also how your brain perceives sound. Just like my eyes could work perfectly, but I may see color differently than the next person because of the way my brain perceives it. So we'll talk about all of those areas. Let's start with physiological, how our ears work. The physiological part of hearing is basically how a sound wave, a pressure sound wave, a disturbance in the air, is modified so your body can understand it, turn it into electrical impulses, and send it to the brain. So in a sense, we're taking kinetic energy of the air motion, molecules, right, that energy of the sound wave, and we're somehow physiologically and biologically converting it into electrical impulses that go to our brain that we can understand. Remember when we talked about the very important concept of transduction? Our ears act as a transducer, converting one form of energy to another form. So we convert acoustic energy to electrical energy so our brain can understand it. Human ears. Everybody's ears are different, very important differences. No two people have the same size ears, same shape ears. All of that is important to our hearing, and so what we're going to discuss right now is the basic human hearing in a general sense, not specifically to any one person. Some people hear better than others, some don't, based upon their physiology, based upon how their brain perceives it. But let's just talk about human hearing in general. So in general, the three parts that make up our physiological hearing, the ear, the anatomy of the ear. There's basically three parts to the ear. There's the outer ear, the middle ear, and the inner ear. They all perform specific functions in our hearing. The outer ear is typically called the outer ear, but it actually goes in a ways into your head, and it goes all the way from the outside of your head, all the way through your ear canal to what's called the tympanic membrane, which is your eardrum. That's called the outer ear. Okay, so your outer ear goes from here is your tympanic membrane, which is basically what people call your eardrum, all the way out is the outer ear. And you notice that there's an ear canal here as well. That's inside your head, but that's considered the outer ear. Okay, then there's the middle ear, and the middle ear goes from the tympanic membrane, which is your eardrum, all the way to this squiggly thing that looks kind of like a snail, but it's called a cochlea. And your middle ear is this little region here in between your eardrum to your cochlea. And then your inner ear starts at the opening to the cochlea and back. Okay, those are the three divisions to hearing or to your ear anatomy that we're going to discuss. And if I haven't made a good enough case for why we're needing to understand hearing and how the ear works, let's put it in a practical sense. If I'm mixing a record as I was doing today, the way I hear is different than the way my client hears it. The way you hear it, the way you hear it, the way I hear it is all different. We perceive it differently, we hear it differently. It may be comfortable for me to listen very quietly and comfortable for you to listen very loudly. But the whole mechanism in a general sense is important to understand, because if we're going to deal with sound, you have to understand what the mechanism is that we can perceive sound. because if I perceive sound a certain way, I'll mix it so it sounds best to me. Similar, like if I wear glasses, right? If I wear different glasses than you do, we're going to see the world differently if we take our glasses off. So we all really want to be able to understand how our hearing actually affects our perception of sound. So when we hear something, I mean, it's typical to think that when I look in the sky and see blue, that's what everybody sees. Everybody sees blue, like I see blue, but it isn't true. Just like when I hear a kick drum or music, other people perceive it differently. My goal as a mix engineer or somebody who's trying to commercially exploit a song of my own or make something that's going to be commercially exploited and listened to by other people, that I can translate the message of what I'm trying to get across based upon how I perceive it and how I understand other people will perceive it. So that's the case for understanding hearing. Not only is it fascinating how the ear works, and it's an amazing biological instrument. In fact, your hearing is far more sensitive and resilient than any mechanical device. But it's very similar, in a sense, to a microphone. Sound comes in and gets turned into electrical impulses. But a man-made microphone can't do nearly as good a job or be as amazing as our hearing. So we're starting at a deficit because we hear better than the equipment we're recording on, pretty much.